So for your GCSEs, you need to know all about plugs and wiring. You can get wiring with either 2 or 3 cores to them. I'm taking a look at a 3-core wire today. If it's a 2-core wire, you will just have the brown and the blue wire. The green and yellow stripy one is something that we'll talk about in a little bit more detail later on. All mains cables have the same kind of features. They have wires which have plastic around the outside. Plastic is used because plastic is a good insulator. In other words, it stops the current from passing through from the mains supply into your hand. They all have copper, so they've got copper on the inside. The copper is an excellent conductor. Now, let's take a look at the first colour. So we have here the brown. The brown, you can see a little label there that says L. L stands for live. Now, the function of the live wire, the brown wire provides the current and is held at a voltage of 230 volts. So the brown is the live wire and provides a current and is held at 230 volts. The blue wire, as you can see here, has an N on it. The N stands for neutral. Now the function of the neutral wire is to complete the circuit. Now the final wire is the earth wire. On here it's represented by that symbol, which is the symbol for earth wire. We're going to talk about what the earth wire does in just a moment. Not all cables will have an earth wire. Now before I write down the function of the earth wire, let's just take a look at how these are all arranged in a plug. So here is a plug. It's a standard mains plug. It's a 3-core plug. It has the diagram on the front, which is live, which goes through the fuse. We'll take a look at the fuse in a moment. You have the neutral here, which goes off to the left, and then you have the earth wire at the top. Let's unscrew it. So this I wired up this morning, and if you take a look, the blue wire goes off to the left, the brown wire goes up to the fuse, and the green and yellow stripy wire goes up to the top. Now normally during lesson we would wire up a plug, but I don't want to do that over the internet because if you do something wrong then the consequences may be severe. So I don't want to give you a tutorial on that. I will give you a couple of tips though. This is called the cable grip, and this stops the wire from being easily pulled out of the bottom of the plug. If you notice, I've been very careful to trim the wires so that the insulation goes pretty much all the way up to these screws. That's very important. Finally, if you notice, I always cut the live wire slightly shorter than the other two. The live wire doesn't have as far to go. So that's really, really important that you do that. It'll make it a lot easier. Final tip is if you are having to wire one of these up, then you can move these out. So sometimes it's difficult to screw it into position if they are all if they're all in situ, but you can push them out and put them back in again. Okay, so let's take a look at the purpose of this green and yellow wire. So here we have our hyper-realistic washing machine. I'm just going to take off the front of the washing machine, and inside you'll find the guts of the washing machine, including the motor and all that kind of stuff. I particularly want you to focus on this bit down here. So this is where the current is brought in by the live wire and the blue wire completes the circuit. And this is the same washing machine, but this time there's an electrical fault. Can you spot what the difference is? Hopefully you will have noticed that the live wire is no longer plugged into the motor. This means that the live wire is touching the casing of the washing machine. That means that if you go and touch the casing of the washing machine, you will then complete the circuit and the current will pass through you. This makes the casing of the washing machine live, as the casing of the washing machine is made out of metal, and there is no insulation protecting you from that current. Hi. Do you like my lockdown hair? This is my Graaff Generator. This accumulates charge on the outside of the dome. Pretty much in the same way that if you had a live wire connected to the inside of a washing machine, then that live wire would be able to transfer charge to the shell of that washing machine. Now let's take a look at what happens when you touch a metal shell that is live. Ow! Ah! You get a transfer of current. That, on a Van de Graaff generator, isn't too much of a problem. But if you did that to a washing machine, where mains electricity and mains current was being transferred to you, you would die. So, how do we solve this issue? Well, let's take a look inside. If you take a look, we still have a fault in that the earth wire is still not connected to the motor as it should be, and it's still touching the casing. The difference here is that we have an earth wire. The earth wire is also touching the casing. Now let's try the same thing again. This time we have a wire that is connecting the shell of the dome to the earth. This is the same as what happens when we have an earth wire connecting the shell of your washing machine to the earth as well. So let's see what happens. I'm not dead! No shots! Because what's happening is that while the dome is trying to charge up, the charge is being drawn through this low resistance wire into the earth. So it doesn't transfer through me, a relatively high resistance kind of person. Isn't that wonderful? And this is what the inside of your washing machine should look like if there are no faults at all. So you see there, the live wire carries the current into the motor, the neutral acts to complete the circuit, and the earth wire remains attached to the outside of the appliance, making sure that there is always a low resistance pathway for any current to travel through, preventing the cover from becoming live and preventing you from getting an electric shock should you touch it. So just to reconfirm, earth wire in, no problem at all. Earth wire out. Okay, so now you've seen the green and yellow wire in action, we can fill in what it does. So just to summarise then, if we take a look at this plug, we have the brown wire which is on the right hand side which provides the current and is held at 230 volts. We have the blue wire which is the neutral wire on the left hand side which is just there to complete the circuit. And finally we have the green and yellow stripy wire that is used to stop the outside of any kind of metal appliance from becoming live. Remember, not all appliances have a metal casing, so therefore they don't all have earth wires. An example of this might be a hairdryer. Okay, so we're going to take a look at a plug. This is just a standard mains plug. You can see here it's got a 13 amp fuse in. This is where the earth wire goes, this is where the neutral, and this is where the live wire goes. Remember, the live wire always goes through the fuse. We're going to take the cover off this. Okay, now this plug hasn't been wired up to anything. So here, this is our 13 amp fuse. Now this is a protective device that's designed to stop you from getting a surge in current into your device. Okay, so what I'm going to do is I'm going to show you a little bit about what they look like. So this is another 13 amp fuse. So I'm going to cut that open for you. So we're going to do a little bit of dissection here. Who says that we don't do dissections in physics? There we are. You can see there's a little filament there surrounded by a ceramic case. What do you think happens to this wire when the current is too high? As a hint, why not have a think about why it might be in a ceramic casing? Pause the video now and write down your predictions. Fuse wire. Okay, snap it up. Okay, similar stuff to this. Okay, so let's summarize how fuses work. If the current gets too high, the wire heats up. The heating melts the wire, breaking the circuit. And now to link back to my previous question about why it might be in a ceramic casing, they're usually contained within either glass or ceramic casings, as these materials are good thermal insulators. In other words, you don't want the rest of the plug heating up.